Hey, what's up guys? क्या हाल चाल? Welcome back to another video. Today we will study about green chemistry, which book is authored Kusum Sharma. We have content in green chemistry, introduction, the 12 principle of green chemistry, hazard and green chemistry and challenges, green chemistry awareness incentives, presidential of green chemistry challenges award, green chemistry in India, typical real world cases of green chemistry. So today we will start our topics by the introduction of green chemistry chapter 1. In the last 250 years, starting after first chemical revolution, chemistry has improved and changed modern life with excellent amenities and services. Unfortunately, this achievement has at a price. Our collective human health, global environment, and non-renewable natural resources are threatened. Our bodies are contaminated with large number of synthetic chemicals, many of which are known to be toxic and carcinogenic, while other remains unstudied for their health effects. They come to us from food, air, water, and dust. We know that many such chemical enters the environment not only from smokestacks, drapenaps, leaky storage tanks, and waste sites, but also as they migrate from the furnitures, textiles, buildings, materials, electronics, toys, personal care products, packaging, and the many more manufactured goods we encounter every day. As a result of many these chemicals are present in indoor air and dust, many are in the food web and in our bodies. The dirty form of the chemistry. Environment is a sphere around us which comprise of some physical and chemical components with which we are interacting and also are a part of it. Due to the development chemical science, the use of chemicals has become a quantity. Same is in the case with our environment. The chemical components in our environment are increasing day by day, of which some can be degraded, but most of them are undegradable. The addition of undegradable products that causes instability, disorder, harm, and discomfort to the ecosystem is termed as pollution. Pollution is creating a risk to the environment. Thus, in the order to reduce the risk of pollution, a system should be introduced that must be reduce the risk by not changing the effect but by changing the cause. Here, can chemistry be dirty? Two types: atmospheric pollutions and aqueous pollution. एटमॉस्फेरिक पॉल्यूशन में आते हैं ग्रीन हाउस इफेक्ट एंड द एनर्जी कंजप्शंस, ओजोन लेयर डिप्लेशंस, फोटोकेमिकल स्मॉग एंड स्मोकिंग. एक्वस पॉल्यूशन में फर्टिलाइजर्स, पेस्टिसाइड्स, इंसेक्टिसाइड्स, इंडस्ट्रियल वेस्ट वाटर, सोलवेंट्स, डिटर्जेंट्स एंड द अर्बन वेस्ट. सॉलिड पॉल्यूशन में आते हैं इंडस्ट्रियल सॉइल, न्यूक्लियर एंड रेडियो एक्टिव वेस्ट, केमिकल रेजिड्यूज. This led to the concept named green chemistry. Green chemistry is an inventive science based on the fundamental research towards the development of new sustainable chemical processes. It is a new approach to an old science. There is a great need to create a new production system in order to prepare the younger generation to get a greener future. Thus, green chemistry is cutting edge of the chemical industry today, and can fundamentally change our lives for the better in the future, assessing environmental concern today. Here, green chemistry is shown by the figure also. In 1919s, green chemistry was defined as utilization of set of principles and the residue reduce the elements eliminates the uses of hazardous substances in the designs, manufacture and the application of chemical products. The term green chemistry was coined by Prof. Paul T. Ancestors is 1991. Green chemistry is the largest and the multifaceted field in chemistry. Green chemistry is also called sustainable chemistry. Now, the term green chemistry is defined as the invention, design, and the application of chemical products and the processes to reduce the eliminate the uses and the generation of hazard substances for the workers and the consumers. This definition of green chemistry starts with the concept of invention and designs. This means that the scientist and the technologist must take into account from the start that what they are looking for, what kind of product, how they are going to design its manufacture and its uses. The impact of chemical products and the chemical processes must be included as design criteria. Hazard consideration of for initial materials and the final products must also be concluded in the performance criteria. Another aspect of the definition is in the phrases uses and the generation of hazard substances. Green chemistry also recognizes that there are significant consequences to the use of hazardous substances ranging from regularity, handling and transport, production of waste and liability issues. Therefore, green chemistry is a tool not only the minimizing negative impact but also has legitimate and the complementary objectives of impact minimization and the processes optimization. Green chemistry applies to the industrial prospect, organic chemistry, inorganic chemistry, biochemistry, analytical chemistry, and even the physical chemistry. Green chemistry is a branch of chemistry which involves pulling together tools, techniques and the technologies. It is helpful to chemists and the chemical engineers in the research, development and production of more eco-friendly and efficient method which may also have significant financial benefits. It is now going to become an essential tool in the field of synthetic chemistry. This is new approach is also known as big environmentally benign chemistry, clean chemistry, atom economy, benign by design chemistry. One obvious but important point: nothing is benign. All substances and all activities have some aspects just by their being. What is being discussed when the term benign by design and the environmentally benign chemistry is used is a simply ideal striving and to make chemistry more benign whenever possible is a merely a goal. Benign chemistry is merely a statement of aiming for perfection. The 12 principle of green chemistry. Paul Anstens and the John Werner moved to produce a set of guidelines that have since been adopted as mantra for the design of environmentally benign process as the 12 principles of green chemistry. These principles comprise instructions for professional chemists to implement new chemical compounds, new syntheses, and new technological processes. The first principle describes the basic idea of green chemistry, that is, protecting the environment from pollution. The remaining principles for focused on such issues as atom economy, toxicity, solvent and other media, consumption of energy, application of raw materials from renewable sources, and the degradation of chemical products to the simple non-toxic substances. They are friendly for environment. The 12 principles are Preventions: it is better to prevent waste than to treat or clean up waste after it has been created. Number 2, atom Atom economy: synthetic methods should be designed to maximize the incorporation of all materials used in the process to the final product. Less hazardous chemical synthesis. Whenever practicable, synthetic method should designated to use and generate substances that possesses little or no toxicity to human health and the environment. Design safer chemicals. Chemical products should be designed to preserve efficiency of function while minimizing the toxicity. Suffer solvents and the auxiliaries the uses of auxiliary substances, solvents, separations, agents, etc. should be made unnecessary whenever possible, and the when uses in the unconscious. Design for energy efficiency. Energy requirements of chemical processes should be recognized for their environmental and economic impacts and should be minimized. Synthetic method should be conduct the ambient temperature and pressure. Use of renewable feedstocks. Raw materials or feedstock should be renewable rather than depleting whenever technically and economically practicable. Reduce derivatives. Unnecessary derivations used for blocking groups, protection, deprotection, temporary modifications of chemical and physical processes should be minimized or avoided if possible, because such steps require additional agents and can generate waste. Catalysis. Catalytic reagents, as selective as possible, are superior to stoichiometric reagents designed for degradation. Chemical products should be designed so that at the end of their function they break down into unconscious degradation products and do not persist in the environment. Real time analysis for pollution preventing. Analytical methodologies need to be further developed to allow for the real time in the process monitoring and the control prior to the formation of hazard substances. Inherently suffers chemistry for accident prevention. Substances and the form of the substance used in the chemical processes should be chosen to minimize the potential for chemical accidents, including releases, explosions, and the fire. Here green chemistry is shown by this structure. Explanation of the 12 principle of green chemistry. Principle number 1, preventions. This principle is a fundamental, most obvious, and the overarches the other principles. It goes back to the old ages, and ounce prevention is worth a pound of cure. Most of the chemical processes and synthetic routes produce waste and toxic secondary substances. Hence, synthesis should be designed as carried out in such a way so that the waste or byproducts formation is minimum. However, it is a best if the byproducts and the waste are not generated at all. Waste generation increases the cost of production, as overall cost of production depends on the cost of disposal of waste, and at the same time clearing up processes also requires expenditure. The discharge of byproducts or waste into atmosphere, land or sea causes pollution also. Sometimes the unreacted starting materials, which may or may not be the hazards, forms parts of the waste. Human beings are depleting resources and making waste much faster. Nature can take the waste and convert them back into resources. This principle is also lead to grinding chemistry. Grinding chemistry, that is, reactants are simply grinded or mixed without solvent, thus reducing the possibility of waste. One of the best example of three-component Friedel-Crafts reactions. Here, indole reacts with aniline in the presence of solvents. Indole derivatives performs. Use of microwaves is an expansion of grinding chemistry or solventless chemistry. Using the technique, triphenyl methane derivative is synthesized as below. Principle number 2. Maximize synthetic methods atom economy. This principle gets into the actual chemistry of how products are made. As chemists, atoms are assembled to make molecules. The molecules are assembled together to make materials. This principle states that it is best to use all the atoms in the process, as those atoms that are not used end up as waste. Originally, the concept of yield was used to account the success of a reaction. This concept is prospective, it is not the full picture. It is because the yield calculated by considering only one reactant and one product. However, such a synthesis may generate byproducts or waste which is not taken into consideration. For example, grinded reaction proceeds with 100% of yield, but in calculations the byproducts MgOHI is not taken into account. The yield of the above synthesis may be 100%, but it is not considered to be green synthesis. That is, synthetic method can be designed in advance to be green synthesis. That is, synthetic method can be designed in advance to maximize the incorporation of all reagents used in the chemical processes into the final products. The concept of atom economy was developed by Barry Trost, for which is received the Presidential Green Chemistry Challenges Awards in 1988. It is a method of expressing how efficiently is a particular reactions make use of reactant atoms. Principle number 3. Less hazardous chemical synthesis. The principle is focused on how we make molecules and materials. This method is used to make chemical materials called synthetic methods. Have often employed toxic chemicals such as cyanide, chlorine, etc. In addition, this method is time generated large quantitative hazard waste. The goal of this principle is to reduce the hazard of the chemicals that are used to make the products. Chemists must strive wherever practical to design the safer synthetic methods by using less toxic substance as well as the products of synthesis. Less toxic materials means lower hazard to workers in industry and the research laboratories and less pollution to the environment. Example: product production of the stearine. Traditional route, it is the two-step method starting with the benzene, which is carcinogenic, and the ethylene to form the ethyl benzene. In the second step, ethyl benzene is catalytically dehydrogenated to obtain the stearine. Greener route. In this route, the instead of benzene, xylene, which is cheapest source of aromatics and the environmentally safer than benzene, is used starting material. Synthetic of polycarbonate. In this synthesis, polymer polycarbonate phosgenes gas was used, which is highly toxic and the corrosive. The above method requires large amount of dichloromethane, the product, and the product polycarbonate contaminated with the chlorine impurities is obtained. In a greener method, polycarbonate is synthesized by solid state process. The advantages of these methods are Phosgene gas is not used. Use of dichloromethane is eliminated. Higher quality of polycarbonate is obtained. Green chemistry principle gives great emphasis to the scientific terms, hazards for the processes, and the life cycle of chemical substances. Green chemistry is the way of dealing with the risks reduction and the pollution prevention by the addressing the intrinsic and the hazard of substances rather than dealing with the condition of their uses. They might increases the risk in its most fundamental terms is the product of hazard and the exposure risk is equal to F. To calculate the risk associated with the certain substances, we have to quantify its hazards, how toxic or dangerous to human and the environment it is, and the multiply it with the quantitatable exposure. In the past, all common approaches to risk reduction was focused on the reducing exposure to hazardous substances. Green chemistry goes to the heart to risk prevention or adequate reduction in the advance before their substance of is made or used. Green chemistry demands to design products and use raw materials with the lower hazardous properties as practical as possible. Nowadays, green chemistry research is developing to make these synthetic methods more efficient and to minimize the waste while also ensuring that the chemical used and generated by these methods are as non-hazardous as possible. For example, a number of industries such as pulp and the paper industry use chlorine compounds in processes that generate toxic chlorinated organic waste. Green chemists have developed a new technology that converts wood pulp into paper using oxygen, water, and the polyoxometalloto salts with while producing only water and carbon dioxide as byproduct. Green chemistry illustrates another important point about the use of the terms hazards. This term is not restricted to physical hazards such as explosiveness, mm, flammability, and the corrosibility, but includes acute and the chronic toxicity and the carcinogenity, fundamental pollution to water, air, and soil, ecological toxicity. Principle 4 Designing safer chemicals. Principle 3 is focused on the process, while principle 4 is focused on the product that is made. This principle is aimed at designing products that are safe and non toxic, and the efficiencies. Thus, green chemistry aims to eliminate the hazard rights at the designing stage. Designing must become the fundamental aim of green chemists to affect the desired function and the properties of chemical product while minimizing their toxicity to human and the environment. From 1980 से there are more stringent regulations and new chemicals are mm, monitored for more effectively. In 1963, thalidomide drugs was used to reduce the effect of morning sickness during pregnancy. Subsequently, it was found that this drug causes serious birth defects in the children born to the woman taking these drugs. The drug was banned and the withdrawn. The more we know about the chemical structures that causes a toxic effect, the more options are available to design a safer chemical. Chemists now have access to many sources of information to determine the potential toxicity of the molecules they design and the ingredients they choose. Green chemists are trained to use this information into the design of the molecules to avoid or reduce toxic properties. For example, this may design they might design a molecule large enough so that it is unable to penetrate deep into the lungs where toxic effect can occur. Similarly, they might change the properties of a molecule to prevent its absorption by the skin of ensure its safe breakdown in the environment. Now polymer have been developed which are much less flammable than the known polymer and also able to absorb serve impacts without cracking and the breaking. One such polymer is polyphenyl sulfone, which is now widely used in the interior panels of aircrafts and the underground trains. Detergents used are sodium salt of alkyl benzene, sulfonic acid with branched alkyl groups. These were not degraded naturally in the phases of works and caused foaming, which made the swag difficult to manage. Now these compounds have been replaced by sodium salt, linear alkyl benzene, sulfonic acid, which are readily degraded. This design of highly selective, environmentally friendly insecticide sponges is in an example of a technological development that demonstrate how a safer chemical can be created and produce. It has a favorable environmental profile. It does not leach bioaccumulative volatiles or persists in environment. It degrades photochemically. Safer solvent and auxiliaries. Traditionally, in organic synthesis, a number of solvent which is with excellent solvent properties are employed. These solvents are mostly volatile organic compounds and includes methylene chloride, chloroform, perchloroethylene, carbon tetrachloride, benzene, and other aromatic hydrocarbons. Out of these solvents, halogenated compounds and the benzene are carcinogenic, while some other solvents have hazardous effect on the environment. Solvents are not only an important liquid medium of synthesis but also for extraction, separation, purification and drying. Solvents are also very important in chemical analytical methodologies, spectrophotometry and the measurements of physiochemical properties. This principle of green chemistry is promote the idea of greener solvents. Replacements in the case of in that case can be substituted with the safer alternatives or changes in the methodologies of organic synthesis when solvents are not needed, that is solvent less synthesis. Some green solvents are water supercritical, carbon dioxide, ionic liquids, polyethylene glycol and its solutions, and fluorous solvents. In this respect, we can quote one of the well known example of nail salons. The solvent traditionally used in the nail salons have potential toxicity. A water based alternative polish would avoid the exposure that goes along with nail products and reduce the hazards associated with the traditional products. Design for energy efficiency. According to this principle, energy requirements should be recognized for their environmental and the economic impacts and should be minimized. Chemists use a lots of energy in heating, drying, and cooling. Energy is not only expensive, most of the time, the power plant that creates the energy contributes to the pollution. Today, there is a focus on renewable energy and the energy conservation. Traditional methods of generating energy have been found to contribute to global environmental problems such as global warming, and the energy used can also be the significant cost. This principle focuses on creating products and materials in a highly efficient manner and reducing the energy associated with creating products, therefore reducing associated pollution and cost. One of the alternate energy source is photochemical reaction. For example, the conversion of cyclohexane to caprolactam can be done photochemically. Other methods includes microwave, ultrasound, etc. Traditional processes are being overhauled and substituted by more energy efficient method. Catalysts are being developing so that the processes can be run at lower temperature and pressure, as high temperature and pressure and are very energy consuming. Similarly, the development of molecular science means those processes such as purification of ethanol can be carried out at ambient temperature instead of by distillation. Waste often has energy content, and it may be possible to convert this is this to a useful fuel. Waste solvent from the manufacture of plants, varnishes, adhesive inks, cleaning fluids, etc. are made into a liquid fuel for use by the cement industry. A solid fuel is also made from the shredded crafts, packing, furniture, plastic, and the paper. Most of the otherwise would be destined for the landfill. A boom is currently occurring in the use of these green energy sources, and this is also associated with a marked decrease in reaction time to higher yields and very often to higher product impurity. Use of renewable feedback. Our society not only depends on the petroleum or transportation and energy, but also making products. This principle is seek to shift our dependence on petroleum and to make products from renewable materials that can be gathered or harvested locally. For example, biodiesel obtained from the biomass is used as an alternative fuel. Polylactic acid, a biodiesel plastic, is being made from the renewable feedstock such as corn and the potato waste. D-glucose is converted into lactic acid using certain enzymes which helps to prepare certain aliphatic compounds from lactic acid. Iso, isomel, isometallose, which is widely available in biomass, can be converted into glucose methylfurfural, which can be used for production of many heterocycle compounds. Beside biomass, cash crop is a new hope as ethanol from the sugar cane has been derived successfully, and how scientists are trying to use this big alcohol as a source of energy for vehicle in future. Reduced derivatives. This principle is perhaps the most abstract principle for a non-chemist. The methods that chemical uses to make products are sometimes highly sophisticated. In many of the methods, chemists manipulate the molecules in order to shape the molecules into what they want them to look. This principle aims to simplify the process and to look at the natural system in order to design products in a simplified manner. Unnecessary derivations such as blocking of groups, protection and deprotections of groups, temporary modification of physical chemical processes should be avoided, as these processes increases synthetic steps which leads to decreases in yield and the atom economy. Bromination of the para or ortho position of aniline without protection of amino group is a process in which protection and deprotection steps have been removed. Catalysis. Catalysts. In a chemical processes, catalysts are used in order to reduce the energy requirement and to make the reaction happen more efficiently. Another benefits of using the catalyst is that general small amounts of catalyst, that is catalytical amount, not stoichiometric amounts, are required to have an effect. Catalytic reagents are superior to stoichiometric reagents. Now the chemical prefer the uses of green catalyst, a catalyst that will have the little to no toxicity and the recyclable, that is can be used over and over again in the process. Enzyme are wonderful green catalysts. Green chemists are investigating using enzymes to perform chemistry in the laboratory in order to obtain the desired product. These biocatalysts have following benefits: fast reaction due to the correct orientation of sites, gives high stereospecificity, substrate specificity, naturally occurring moderate condition, possibility possibility of random reactions. For many years, aluminum chloride was used as an active surfactant in the production of alkyl benzene sulfonates and in the other detergents. The aluminum chloride cannot be recycled and become waste as aluminum hydroxide and oxide. Now the zeolates catalyst with acid groups is used and can be reused many times without yielding any waste. Design or degradation. Not only we want materials and the products to come from renewable resources, but we would also like them not to persist in the environment. Hence chemical products should be designed in such a way so that at the end of their function they do not persist in the environment and break down into in incautious degradation products. Design for the degradation means when green chemists design a new chemical such as a pharmaceutical drugs or medicines or new materials such as a plastic, they should design it in such a way that at the end of its useful lifetime its breakdowns. Early example of chemicals persistence in the environment are sulfonated chlorofluorocarbons, DDT, plastic, antibiotics, etc. Plastic do not degrade in our landfill, and the pharmaceutical drugs such as antibiotic accumulate the built up in the water our water stream. Recently developed polylactic and the acid polymer can be recycled and the composted. This approach is the best exemplified by the creation of biodegradable green polymers. Conventional polymers such as polyethylene and the propylene persist for many years after disposal. On the contrary, and the biodegradable polymers are degraded by enzymatic action of microorganisms such as bacteria, fungi, and the algae after the disposals. Real time analysis for pollution prevention. In making the product, if there was a way to see the inside the reactions and to know exactly when it would be done, this would reduce the waste in the process and ensure to make your product is done and the right product to you intend to make. The thus real time analysis for a chemist is a process of checking the progress of a chemical reaction and as it happens. Knowing when your product to be done can save not only loads of waste but also time and energy. Hence analytical methodologies need to be further developed to allow for real time in process monitoring, the control prior to the formation of hazardous substances. The sensor or in analytical chemistry will have particularly important role to play. In recent time, microfabricating microfluidic analytical device are used. These devices are referred to as lab on a chip device. In this device, sample pre-treatment such as a pre-concentration extractions, chemical, biochemicals, diversifications, reactions, electrophoretic separations, detections have been carried out on a single microchip platform inherently safer chemicals for accident prevention. This principle focused on the safety of workers and the surrounding community where industry resides. It is better to use in the chemical process substances and the materials which would minimize the potential for chemical accidents such as explosions, catch fire, or ignitions in air. There are many examples where safe chemicals were not used, and the result was disasters. The most widely known and perhaps one of the most devastating disasters was that of Bhopal, India, in 1984, where a chemical plant had a accidental releases that resulted in thousands of lives lost and many more injuries. The chemical reactions that occurred was a exothermic reactions that went astray and toxic fumes were released to the surroundings. So while creating products, it is the best to avoid highly reactive chemicals that have potential to result in the accidents. In the synthesis of most widely used herbicides, glyphosates, sodium salt of 2,2-amino diethanoic acids, one of the intermediates. This intermediate is made by series of reactions from ammonia, methanol, and hydrogen cyanide. All through hydrogen cyanide is very useful reagent. It is extremely toxic. A reactant innovations has been in the introduction of new route of the sodium salt. The starting materials are ammonia and the epoxyethane epoxyethane, which is on the reactions from 2 to immunodiethanol often name named as diethanolamine. This is then converted to the sodium salt of 2,2-aminodiethanoic acid. Thus, thus, in the event of an accident, the consequence would not be as serious and cleanup would be simpler. Tongue Ital very clearly and beautifully condenses the 12 principles of green chemistry to a single word: productively. Productively, principle of green chemistry. P. Productively. All through in the conducting a chemical process, efforts are always being made to the fulfill and the 12 principle, but practically it is not feasible to satisfy the all conditions. Hence the word green is used to comparative degree by comparing with gray chemical processes. In this way, a chemical process is the greener than other chemical processes as fulfill more conditions in the 12 principle hazards and the green chemistry. Green chemistry is an approach that aims to eliminate the uses and the generation of hazardous substances by designing better manufacturing process for chemical products, specifically the goal of making the finished products and byproducts less toxic directs to the decisions inhaled during the chemical production. The manufacture processes includes the aspects of initial selection of chemicals and the mechanism of the chemical synthesis. The end of the products is process and the management of toxic products generated during the products. It means that the green chemistry principles should be applied to the aspect of the product's life cycle from its invention to the disposals, including environment's fate after the uses, potential risks. At the heart of the green chemistry is recognition that hazard is simply another property of a chemical substances. Properties of chemicals are caused by their molecular structures. They can be modified by changing that structures. One of the greatest strengths of green chemistry is its focus on a molecular basis of molecular basis of toxicity. Through an understanding of a mechanism of the action of toxicity both in the body and within the ecosystem, green chemistry engages to design the molecular structure of that inherently either incapable of manifesting a particular toxic endpoint or a maximum greatly disfavoring these toxic mechanisms. These principles and the techniques are applied to the substance ranging from the dyes to pesticides. Regarding toxicity, according to the Pericles, everything is a toxic. It is a simply a matter of dose. This is citizens is taken as a reminder on one can never say that something possesses no toxicity. The types of hazard that can be addressed by green chemistry vary. They include physical hazards, toxicity, or global hazards by limiting the hazards intrinsic to the chemical products. The risk introduced by the product is consequently reduced. There are two major aspects of risk: hazards presented by the products of process and the exposure of humans and other potential targets to those are hazard. A hazard can be defined as a situation which may be lead to the harm. Whilst risk is a probability that harm will occur. This relationship simply states that the risk is a function of hazard times exposure. It shows that risks can be reduced by a reduction of hazard, a reduction of exposure, and various combination of both. One way to reduce risks is to limit the exposure by some physical means or by introduction of system and working practice. Here the hazard remains but the exposure to it is reduced. Such efforts have used various kinds of controls and protective measure to limit exposure. The most common example of such a measure is wearing safety goggles around eyes. Google will not be themselves preventing acids from splashing into the faces, but they protect eyes from the any damage. Explosions shield will not preventing explosions, but they do not protect chemists or other the violently from any harm. Thus, reduction of exposures is effective preventing injury and the harm. The alternative way to minimize the risk is a green chemistry approaches, according to which is to reduce the hazard. The hazard diminished or eliminated at its resources. Measures still may be taken to reduce exposure to remaining hazards. This approach gets to the root causes to the problem, and it is based on the principle of what you don't have can't harm you. Protective measures are the most effective against acute effects but less so against long term chronic exposures that may cause toxic response over many periods of times were feasible and hazard for you. The parts of the same can be done with water. Solution is a non-toxic cleaning agents used for the same purpose. The use of organic solvent requires constant vigilance to avoid the such as formation of explosive mixture with air, presence of ignition source that could result in a fire, and excessive exposure by inhalation of absorption through skin that might causes peripheral neuropathy in works. Failure of the protective measures can result in a bad accidents or serious harms to workers' health. The water-based cleaning solution, however, would not present any of these hazards, so that failure of prospective measures would not create a problem. Green chemistry and challenges. Sustainability. It is just a one word, but still there are 300 definition of it. The word sustainability is derived from the Latin word sustain. According to the dictionary, there are more than the one meaning of sustain, but mainly in it is taken into maintain, support, or endure. The most quoted definition of sustainability are the and sustainable development that of Bartland definition of Commission of United Nations. Sustainable development that meets the needs of the present without compromising the ability of future generations to meet their own needs. The three pillars of sustainability are the environmental, social, and economic demands. These three pillars are expressed by their overlapping ellipse, overlapping ellipse, which is point out these three pillars are not mutually exclusive and be mutually reinforcing. Another representation of sustainability it shows that how both economic and the society constrained by environmental limits. Green chemistry is sustainable chemistry. There are several important respects in which green chemistry is sustainable, economic, and at a high level of sophistication. Green chemistry normally costs less is strictly economic terms than chemistry, as it is normally practiced materials by efficiently using materials, maximum recycling, and the minimum use of virgin raw materials. Green chemistry is sustainable with respect to the materials waste by reducing insofar as possible or even totally eliminating their productions. Green chemistry is sustainable with respect to waste. Green chemistry and challenges. In the glorious day of 1950 and 1960, chemists invented chemistry as the solution to a host of society's need. Indeed, they created many things such as dyes, paints, plastic, cosmetics, and other materials which improved the quality of life on the earth. At the same time, chemistry brought a medical revolution through antibiotic. All these things proves DuPont slogans, better things for the better living through chemistry. But these achievements has come at a price of global environment and the non-renewable natural resources. Sustainability is at stake, and the continuations of equality of life under threat. Many chemicals works their way up the food chain and the circulate around the globe. Pesticides reduces were found Residues were found in the tropics and the Erratics flames retardants from the electronics are now commonly found in the aquatic organisms, especially in the marine mammals. How sustainability is defined. According to the Bertillon Commission, sustainability is defined as the ability to meet the needs of the current generation while preserving the ability of future generation to meet their needs. A simpler way to expressing this idea may be preserving the things you cannot live without preserving them forever. What role does green chemistry has to play to these challenges and the ultimate goal of sustainability? Green chemistry fulfills the fundamental and the cross-cutting role that is essential to the critical pathway towards sustainability. Green chemistry and its 10 principles want to change all this negative impact and through the design invention and the green process restore the plant sustainable development. Simplify state it is difficult to imagine a way to address the challenges of sustainability without engaging the green chemistry. The green chemistry revolutions itself is providing to enormous number of challenges to those who practice them in industry, education, and research. With these challenges, however, there are equal number of opportunities to discover and apply new chemistry to improve the economic manufacture and to enhance the much as transit image of chemistry. The term of sustainable chemistry proposed in the beginning was changed to green because the meaning of radical change, inventions, rejection of old attitudes and practices. All through many chemists and some of large and smaller companies are actively preserving green chemistry. There are still many barriers to the green chemistry. The most pressing issues to the planet facing are known as a solution of enable the use of low environmental impact renewable feedstocks, drop in the chemical or materials from biological input versus constrained resources as such as petroleum. With the increasing population, the raw materials extracted from the earth are depleting in the in that they are in the finite supply that cannot replenished after they are used. Renewable resources utilization is a central tenet of green chemistry and a very active area of engagement. Use of biomass as feedstock is being developed in everything from the polyesters materials and the fuels. The use of nanoscience is beginning to be pursued to the achieve materials efficiency through green chemistry that will have potential applications from computing sustainability non-conventional biomass such as seafood byproducts. Example to be developed into materials like ketosins materials and the energy sources that may have once be viewed as the waste into the value added renewable materials solutions that increases energy water and raw materials efficiency, minimize the use of concentrated resources energy consumption possesses economic and the environmental costs in the virtually all the synthetic and the manufacture processes. Therefore energy requirements should be minimized. Currently the energy supply of wood world is largely based on the combustions of carbon, the extraction of or collection of carbon through mining, drilling, processing, etc. has well documented environmental consequence. The production of carbon dioxide and other gases has been cited as contribute to the global warming. The generation of associated toxics during the production of fossil fuels and the rate at which these finite resources is being depleted are also areas of environmental concerns. Green chemistry, however, engaged in addressing energy needs through the development of more sustainable energy technologies. The principle of green chemistry are being employed in the development of the hydrogen economic and the fuel cells. The sustainable sources of hydrogen generation in an economically sustainable manner are an area of active research both in green chemistry and the green engineering. The design and the development of photovoltaic and the solar energy devices that are both economically viable and also ensure a positive energy balance through their manufacture and use is being pursued. Material that are needed to make the wind and the geothermal energy systems possible are being developed through green chemistry researches. The energy future will need to be shifted to a more sustainable balance, and the green chemistry is essential in making that shift happen. Water, the molecule most associated with life on the earth, is also one of the greatest challenges is sustainability in the 21st century. In many countries, water shortage stem from the insufficient use, degradation of available water by pollution, and the unsustainable uses of underground water. Green chemistry is improving water supply and the water quality through the prevention contaminations and the more environmentally being benign treatments method. Green chemistry is also being engaged to find more sustainable way purify drinking water with the use of chlorine free disinfection agents. Water can be both pure and also known not contribute to the generation of toxic and bioaccumulate substances. Thank you guys.